Hello, my name is Mr. Asprey, and this is my EDEXCEL A-Level Maths 2026 Predicted Practice Paper 3. Now, can I have 2 minutes of your time to explain 3 really important points? And that is number 1, the most important of all, and that is disclaimer. Nobody knows what's going to be on paper 3. There is no guarantee whatsoever that any of these topics will come up on paper 3. Most important thing is that you revise thoroughly. Number 2, if you really enjoy my content and you would like to attend my live revision session where you can watch me do tricky questions like this live, then I've compiled 2 more predicted practice paper 3s for that session that is happening on Sunday the 14th of June. You can get tickets, the link is in the description. And also, if you are interested, I will talk more about the session and give you more details at the end of the video and explain why they are so great. But one more thing, that if you are interested, I would recommend signing up quickly, as I suspect they are going to be selling out very, very soon. Third and final point, and that is to download the paper from my Google Drive and try it yourself before watching the video solutions. Try and do it under time conditions if you can, and then afterwards you could come back and watch the video solutions to get all the answers and also some very helpful tips along the way. Now, I've compiled these papers using questions that are not from the EDEXCEL past paper set, because I suspect most students will have done the majority of, if not all of, the EDEXCEL past papers. So these questions will feel fresh and will not overlap with your just regular revision. And if you haven't done the EDEXCEL past papers yet, then you can watch my videos as you go through them, so hopefully support you on your journey through those past papers. Okay, I think that is my 2 minutes up, so I will now get into the video, and if you do enjoy the content, then please do like and subscribe. Question number 1, correlation. And we've got a researcher who plans to do a test whether or not there is linear correlation between time from conception to birth and the birth weight of newborn babies. Explain why a one-tailed test is appropriate in this context. Well, it doesn't specifically say which direction the correlation is going to be tested for. So one would assume, if that's the case, you would use a two-tailed test. But if we just look at the context of the question and the fact that we are being told to explain why a one-tailed test is appropriate, we would conclude that it's because we would expect only a positive correlation, because literally the longer time from conception to birth, then the more likely it is that the baby will have a greater weight. So remember, whenever you are explaining a question, then you must give context. So the context is the 2 variables are conception to birth time and then the birth weight. So always make sure that you link that into your final answer. Okay, now moving on to part B. And the key points here are that we have 11 babies in the sample, and we have the correlation coefficient given for the test statistic of being 0.722. So what we will need to do is we will need to find the critical value. Let's label that part A. Part B, then we need to find the, before we find the critical value, of course, we need to set out the hypotheses. And that is that rho is equal to 0, which means the null hypothesis is such that there is no correlation between the 2 variables. And here, rho is greater than 0 because we're testing for positive correlation. Okay, now we can find the critical value. And that critical value will be found in the formula book. And we need to use a 1% significance for n is equal to 11. Okay, so let's grab the book here and turn to the correct page, and this is a little screenshot of that page, and we are looking at a 1% and we are looking at 11 sample size. So this there is where that row and column intersect. So we can say critical value is equal to 0.6851. Now we need to compare that to the actual test statistic. And we can see here that the test statistic is bigger than the critical value, which means that these two variables are very well correlated. So we can conclude then that we need to reject H0 and accept H1. So what I would write is this. I would say that there is sufficient evidence at the 1% significance level to reject H0, and then super important, you must again put context. You must link the two variables that you're actually testing correlation for, and you say conclude that there is positive correlation between time from conception to birth and birth weight. And there we go. Okay, question number 2, and we have the lengths of pebbles that are summarized, and it says that we're going to be using a histogram drawn to represent these data. I always find that weird when you pluralize data, you have to say these data. Anyway, the bar representing the class of this one here we're given 2.5 wide and 7.5 tall. Okay, and then we need to calculate the height and width of this bar here. So the first thing I'm going to do is I'm going to write out the class widths like that. Oh gosh, it's so hot here at the moment that it's really hard to use my pen. Anyway, class widths and then the frequency density. So the class width is the gap between the end and start point of the class, and that is 10 there, it's 2 there, and it's 4 there. And in fact, these are the only two ones we're actually concerned about, is this one and this one. So I'll just stop there. Now the frequency density is the frequency divided by the class width. So 16 divided by 2 is 8. And here, 20 divided by 4 is 5. Okay, lovely. Now, what can we do? Well, we can look at the, let's look at the class widths first. Okay, so I'm going to go down to here so I can actually write my answers. So for part A, we can say that the class widths are, oh no, what are they? So this one is 2, and that one is 4, and the 4 represents a width of 2.5 centimeters. Okay, so a class width of 4 represents 2.5 centimeters. So the interval that we're concerned about, that we want to find the width for, has a class width of 2. Okay, so if it has a class width of 2, then the ratio will apply and it will be half the number of centimeters. So there we go, there's the class width. And now let's look at the frequency density, because the frequency density of a histogram is the y-axis, which is the height. So the one which we know is 7.5 tall, and it has a frequency density of 5, because it's this this interval here. So it has a frequency density of 5, and it is 7.5 tall. So we can say that a frequency density of 5 is going to give us 7.5 centimeters in height. And we're interested in this one, which has a frequency density of 8. So down below we can say frequency density of 8. So how is that going to scale up? Well, we're going to take our 7.5 and we're going to divide it by 5, and that will give us the height when the frequency density is 1, and we times it by 8, and that will give us the height when the frequency density is 8. So that gives us a height of 12 centimeters. Okay, so the answer is width equal to 2.5 centimeters and height equal to 12 centimeters. Perfect. Okay. Now it says using the linear interpolation, estimate the median of x. Well, the median is in the 50th position. So if we count up as we go along, we've got 2 plus 16 is 18. In fact, we could do the cumulative frequency over here. So that is 2, 18, and then add on 20 gives us 38. So we get the first 18 occur when we end this interval, and then therefore the 25th must be in this interval because it goes from 18 all the way to 38. Okay, so let's draw out that interval down here. So that interval goes from 32 to 36. So it goes from 32 to 36. And in terms of the frequency, it goes from 18 up to 38. And the medium is in the 25th position. So let's work out what that value is. We'll call it Q2 for the median. Okay, so for linear interpolation, this is what I do. I say that the fraction of the interval, so that gap there divided by the whole interval. So Q2 minus 32 over 36 minus 32 is equal to the same on the top of the number line, which is that gap there as a fraction of the whole interval. So that gap there will be 25 minus 18, and then divided by the whole interval, which is 38 minus 18. Okay, so we can solve for Q2 now using our calculator. So we can just do on the top, we've got 25 minus 18, and then we're going to divide that by 18. Sorry, 38 minus 18 is just 20. Okay, so let's just show one little line of working here, just to make sure everyone's clear what we're doing. The bottom of that fraction is just 4, and this has worked out as 7 over 20. So therefore we can find Q2 by timesing that 7 over 20 by 4, and then adding on 32. Okay, great. Now let's format that to get 33.4 as our median. Okay, great. Okay, let's move on then to part C. And we have the data here, and it has been coded. So we have Y's and W's, and we have all of the data for Y, so that's after the coding. And it says show that the mean of W is equal to 40.8. Well, we need to find the mean of Y and then apply the code once we've found that. So the mean is the sum of the Y's divided by the number of data points. So we say the mean of Y is equal to the sum of Y over the number of data points. Okay, so that's 104 over 50. So we say 104 over 50, and then we can obviously calculate that. So 104 divided by 50 is going to be 2.08. Okay, now let's look at the code. It says that 10 lots of Y minus is equal to Y minus 20. So we know that 10 lots of Y is equal to W minus 20. And when we are converting between means, whether we multiply or subtract or add in the code, all of that is going to be applied because the mean is affected by both multiplication and addition. So we can rearrange this for W. So it would be 10 lots of Y plus 20. So this is 10 lots of 2.08 plus 20, which is going to be 40.8. as required. Okay, perfect. Now it says calculate the standard deviation of W. Well, we need to first, again, find the standard deviation of Y. So we're going to apply the formula for standard deviation. So for part D, the formula is that the standard deviation of Y is going to equal the square root of Y, the sum of the Y squares over N, minus the sum of Y over N all squared, like so. Okay, so we can just then put in the values. So for the sum of the Y squareds, it's 233.54. So 233.54, and that's all over 50. And then this guy in here is the mean. So we know what that is already. We were told that that is 40 point, no, we weren't. We worked that out to be 2.08. So just to save a bit of time, we could just put that straight in like that and then square it. Okay, so let me put this into my calculator. Okay, so in it goes, and then press execute. And we get this. That's that 0.589, 7. Okay, now what to know is that if you are converting a code and you are converting the standard deviation, addition and subtraction do not matter because they do not change the spread of the data. If you move every data point along 5, let's say, then that's not going to spread the data out at all. But multiplication obviously does. So it means that the standard deviation of W is just going to equal, well, you can see here that W is equal to 10Y. So it's going to be equal to 10 lots of the standard deviation of Y. And again, the plus 20 does not come into play here because we're talking about standard deviation, which is a measure of spread. Okay, so there we go then. All we need to do is just do 10 multiplied by 0.87, which is obviously going to give us 5.87. Okay, so the next part says that the weight of a pebble recorded as 40.8 grams is added to the sample. Now that is exactly the mean. And it says state, without doing any further calculations, with a reason, what effect that would have on the value of the mean. Well, it wouldn't change the mean at all. The mean would stay the same because you're adding on another value, which is exactly the same as the mean. So it's not going to stretch it. It's not going to make the average bigger. That's what would happen if you added a value which was bigger than the mean. That would obviously increase the mean. And if it was below, it would decrease the mean. But if it's exactly the mean, well, the mean will stay the same. And the standard deviation, well, the standard deviation is a measure of spread. It's actually a measure of, on average, how far away are the data points from the mean. So if you add in 40.8, that has 0 spread. That is exactly the mean. So it's 0 spread. So that's going to reduce the average spread. So it's going to reduce the standard deviation. So this is what I would write. So I would say that the mean would stay the same because the new pebble weight has weight which is exactly equal to the mean, and the standard deviation would decrease. That's because the new pebble adds no extra spread and hence makes the average spread of the data decrease. Perfect. Probability, and we've got Venn diagrams A, B, and C, and we've got some probabilities. We know that the events A and C are independent, and A is equal to 0.65. That's going to be useful. But first off, for 1 mark, it just says state which of the 2 events are mutually exclusive. Well, they're mutually exclusive if they have no intersection. So we say B and C as the set B and C is empty. Okay, so that means that they are mutually exclusive if they have no intersection. Great. So on to part B now. So that answer is B and C. Okay, they don't overlap. Now next it says find the value of R and the value of S. So for 5 marks, so we're going to have to use some information, aren't we? And this bit of information is critical, and that is that they're independent. So it means that if they're independent, the probability of A multiplied by the probability of C is equal to the probability of the intersection of A and C. That's the formula for independence that you need to know. Okay, so we know the probability of A, so we can put that in. That's 0.65. The probability of C is R plus 0.13, because that's all of the things that are inside the circle of C. And that's equal to the intersection of A and C, where A and C overlap, which is this guy here, which is 0.13. Okay, so we can divide both sides by 0.65, and when we do that, we get 0.13 over 0.65, which is equal to a fifth, so 0.2. And that means that R is James Bond 007. Brilliant. How exciting. Great news, that. Great news. Okay, but that's not the end of the question, because it's also asking us to find S. Now, let's think about this. Well, yes, S is everything that is not A or B. So we can use the union formula for this. So the union formula goes as follows. So the probability of A union C is equal to the probability of A plus the probability of C minus the intersection of A and C. Like that. That's the union formula, which is very useful to know. Because the union is, in this case, everything but not S. Okay, so everything is inside A or C, but not S. So everything but S is 1 minus S. And the probability of A, we know that, is equal to this. The probability of C, we now know that because we know this is 007. So C is a total of 0.2. And the intersection we know is equal to this as well. Okay, so perfect. So let's just tidy this up a bit. And we've got 65, 0.65 plus 0.2 is 0.85, minus 0.13 is 0.72. Okay, so clearly here S must equal 0.28. Perfect. Okay, so the reason why I use that formula there is because I spotted that S was just outside of the union of A and C. So using the union formula would be very helpful there. Okay, great. Right, now moving on to the next part. I actually labeled that part C, which I didn't mean to. That's actually a continuation of part B, isn't it? Okay, great. But now we're on to part C. It says the events A and C dash and B union C are also independent. Okay, so what we need to do is figure out what these two sets are, don't we? Because without it, then we're going to be a bit of trouble. So let's use a bit of shading to work that out. So let's call this one the blue set, and that is that A intersects with not C. So where is it A and also not C? Well, that must be this guy in here, right? This is A and is not in C. So that is P plus Q. So we can say that the probability of A and not C is P plus Q. And then the other set, which would be helpful if we worked out, was the probability of B union C. So let's go shade that in a different color. Let's use blue and yellow because when they intersect, it gives us green, which is very helpful. So B union C is all of the things which are in B or C or both. So that's C and that's B. Okay, great. So we know that's going to be 0.2 and then plus Q as well. So this is equal to 0.2 plus Q. Now, we also know that because they're independent, then when we multiply the two probabilities, it should equal the intersection of those two things. So what is the probability of the intersection of these two sets? Well, we can look at our shading to work that out, because the intersection will be where the two colors meet, and where blue meets yellow we get green, so it must be just Q. Okay, great. So now that we know that, we can take all this information and we can use the independence formula, which is going to tell us that the probability of each of these individual ones multiplied will equal the intersection of the two. So this will tell us that P plus Q multiplied by 0.2 plus Q will equal the intersection, which is just Q. Now that's not nice because we've got two unknowns there. We've got P and Q, so maybe we need some more information. So so we know S, don't we? So we know S now is 0.28, which means we know what P plus Q is, because P and Q are the only ones that are missing in the Venn diagram. So if we do 1 minus this, and this, we get 0.52. Okay, so we know that. So let's use that. So we do 0.52 there, and we're going to multiply that by this still, and it's going to equal that. Let's expand out those brackets then. So we'll do this multiplied by this. Ugh. Okay, so we get 0.104 plus 0.52 Q, and that's going to equal Q. We can minus that 0.52 Q from 1 Q. So we do 1 minus 0.52, and we get obviously 0.48. So that's the number of Qs on that side. And then we divide through to find Q. So we do 0.104 divided by 0.48. And we get 13 over 60. Let's best leave it as a fraction like that, because that's exact form. I want to round up a decimal. That's perfect. Okay, so now we know what Q is. We can then work out P, because we know that P plus Q equals 0.52. So P is equal to 0.52 minus Q, which is 13 over 60. So we do 0.52 minus previous answer, and we get that, again, leave that as a fraction. Perfect. Question 4 is on discrete random variables, and we have a probability distribution modeled as such, and we need to work out the constant K. So in order to do that, we're going to use the age-old probability formula, and that is that for a discrete random variable like this, all of the probabilities must add up to 1. So that means that the probability that x equals 1 is the first thing we're allowed, and then after that it's the probability that x is equal to 2, and x could also be 3, and x could also be 4, and then finally, well, that is all it could possibly be, so that needs to add to make 1. Okay, so now let's find each of the probabilities. So it just says that the probability is always going to be equal to k divided by x. So when x is 1, this is going to be k over 1, which is just k. And then the next one, when x is 2, will be k over 2. And then the next one will be k over 3. And the next one will be k over 4. And that's equal to 1. We can multiply through by the common denominator, which will be 12. So we get 12k plus 6k plus 4k plus 3k is equal to 12. Add those all up, and that's going to give us 25k is equal to 12. So therefore k is equal to 12 over 25. Very good. And then it asks us to show the probabilities in a table. So we can do that. We can draw our table. We can write x here, and then the probability that x equals x on the bottom. Okay, and then we can draw a line across here. So x can be 1, 2, 3, 4, 4. And we know that the probability is going to equal k divided by whatever the x value is. So k is 12 over 25, divided by 1 just gives us 12 over 25. Divided by 2 gives us 6 over 25. Divide k by 3 will give us 4 over 25. And divide by 4 will give us 3 over 25. Perfect. So that's our table. Okay, now it says that the values of 3 independent observations of x are denoted as x1, x2, x3. Find the probability that x1 is greater than x2 plus x3. Okay, so we need to think about the possibilities that can happen if we take 3 independent observations of x. So we get x1, we get x2, we get x3. We can think of it as like a triplet. So we know that we want x1 to be bigger than x2 plus x3. The smallest x2 plus x3 can be is 2. And that happens when each of them are 1. So that means that the first one, in order to be bigger than the sum of those two, it needs to be at least 3. So one possibility is 3, 1, 1, because again, the first one is bigger than the sum of the next two, which is what we're looking for. Or we could have 4, 1, and 1. That would work. Now, what if one of the other two, so 2 or 3, x2 or x3, were 2? Well, they couldn't both be 2, because if we had 2, 2, then the highest this one could be was 4, which means it's not bigger than those two added together. But you could have 2, 1. And you could also have 1, 2. Perfect. So those are the 4 ways in which we can get the first observation being bigger than the sum of the next two. So we just need to work out the probabilities of this happening. So the first one being a 3, well, we can see the probabilities up here. 3 is 4 out of 25. And then a 1 will be 12 out of 25. And then another 12 out of 25. So we can just square this. And of course, we're multiplying these together because they're independent observations. So we can multiply them together. Because if one thing happens after the other, then you multiply probabilities. So the next one would be 3 out of 25, and then a 1 followed by 1 again is 12 out of 25 squared. The next one is a 4, and then a 2 is 6 over 25, and then followed by 1 is 12 over 25. And this one, again, a 4 would be this, a 1 would be this, and a 2 would be this. Now you may notice as well that these two, the bottom two, are exactly the same, so you could just work out one of them and then double it. But yeah. Okay, now I'm going to find each of these probabilities. Okay, great. So I've just worked them out individually, and then each of these outcomes give us the success that we want. So we're going to add them together, and we're going to say that the probability that x1 is greater than x2 plus x3 is going to equal the sum of all of these. So adding up all of the green ones gives us 288 over 3125. And that's for our final answer. Perfect. Okay, on to part D, where it says that a player plays a game in which they record the value of x twice, and a player wins if the sum of the two values recorded is less than 5. So that means that x1 plus x2 is less than 5, which is also the same as being less than or equal to 4. So if you're less than 5, then the largest you could be is actually 4. And then it says, given that the player wins a prize, so we know that that's going to occur. The question is asking, what's the probability that the first value, so x1, recorded was 1? So we want this to be that x1 is 1. Okay, given this is true. Okay, so we can write that out formally using the conditional probability formula. So we can say that the probability of what we want to happen, which is that x1 equals 1, given what's already happened, which is that x1 plus x2, we know is going to be less than or equal to 4. And the probability, conditional probability formula states that if we want to work out A given B, then we do the probability of A intersection B over the probability of B. So we can say this is what we're trying to work out, is the probability of x1 equaling 1 and x1 plus x2 being less than or equal to 4, that's the intersection, over what is given, and that is that the probability of x1 plus x2 is less than or equal to 4. Okay, so let's start off with the top then. So how can we have x1 is 1 and x1 plus x2 is less than or equal to 4? Well, the only ways that can happen is if we have 1, 1, because there the first one is 1 and the sum is less than 4, or 1, 2, or 1, 3. Can't have any more than that. Again, the first one has to be 1, and then they have to add up to less than or equal to 4. So those are the only options for the top line. The bottom line, how can we have them adding up to 4? Well, it could be 1, 1, or 1, 2, or 1, 3. And then we will need 2, 1. Yeah, because that does the job. That's definitely less than 4. And then we can have 2, 2, which is good. We can't have 2, 3, of course, because that's 5. And so we have 3 in the first slot, and then only 1 would work there. So those are all the possibilities that will give us x1 plus x2 is less than or equal to 4. Okay, so now let's bring back our table of probabilities so that we can actually work this sum out. Okay, and what I'm going to do is I'm going to notice, because all the probabilities are over 25, I'm just going to take out a 1 over 25 squared, in fact, 1 over 25 squared. And let me show you why I'd do that. So the first probability, which we need to work out, is 1 followed by a 1. So that happens when we do 12 over 25 times 12 over 25. But because I've taken out a 25, a 25th, and another 25th, then I don't need to write that over 25 and over 25. So that's just going to save me a bit of time in my working, because it's going to be the same for all of them. So 1 and 2 is going to be 12 times 6. We're going to add these together because each of these are outcomes that are going to give us the success needed. And then 1 and 3 would be 12 times 4. Okay, and then that's all over. Then on the bottom, we're going to do exactly the same thing. We're going to take out that 1 over 25 squared. And then, well, the first 3 on the bottom are exactly the same as the first 3 on the top. So we'll be doing the same calculation. And then you've got 2, 1, which will be a 6 times by a 12. And then we've got a 2, 2, which will be a 6 times by a 6. And then we've got a 3, 1, which will be a 4 times by a 12. Okay, perfect. So let's just extend that fraction line on there. And then, you know, as you can see here, that's obviously, those are going to cancel. So we can just put that into our calculator, which I'll do now. Okay, great. So I've typed it into the calculator, and that has given me 22 over 35, and that's going to be our final answer. Lovely. Okay, we have binomial hypothesis test. Rowan believes that 35% of the vacuum tubes shatter when exposed to alternating high and low temperatures. And Rowan believes it's going to take a sample of 15. So we'll start off by saying X is binomially distributed, a sample of 15, and the probability of one of them shattering historically has been 0.35. Then it says, give 2 assumptions in context that Rowan must make for a binomial distribution to be a suitable model. Okay, well, here are the 4 assumptions that one needs to make for a binomial distribution. So I'll give you 4 rather than 2. Lucky day, hey? So it says each vacuum tube either shatters or does not shatter, so 2 outcomes. The probability that a tube shatters is constant. Tubes shatter independently of each other, and the number of tubes tested is fixed. Now notice each of those I've written down has the context of the question embedded in it. Okay, so please don't just write independent or don't write 2 outcomes. Really make sure that you just spend that extra second putting the actual context of the question into the assumption in order to ensure that you'll get the marks. Okay, now it says, by using a binomial distribution, find the critical region for the test. And you've got to read this nice and carefully, because it does say that rejection in each tail should be as close to 0.025 as possible. So not necessarily has to be smaller than 2.5%. It just says has to be as close to it as possible. So for part B, because it's a 2-tailed test, which was stated, I believe, a bit higher up, actually, which I didn't read out. Yes, a 2-tailed test, as it says there. It means that the critical region, there's going to be an upper and a lower. So if we look at the lower tail first, it's always easier to work out the lower tail. We are looking for a particular value, let's call it C, such that the probability less than or equal to it is going to be not less than 0.025, but actually approximately as close to as possible, 0.025. Okay, so this is where we're going to go to our calculator. Now, some people might just do this by spamming numbers, or you can use the list functionality. I'm going to use the list functionality. All the outcomes I'll put in like so. Takes a second, but there's only 15 possibilities, so, or 16 actually, because you came up with 0. Hit that, then yeah, number of trials 15, probability we're going to assume constant, and then it says we're going to execute. Okay, so here we go. So these are the cumulative probabilities, and you can see here that the one which is closest to 2.5% is definitely this one here, which is X is less than or equal to 1. So we can say the probability that X is less than or equal to 1 is equal to 0.0141. Great, so we can box that up. That's important, and it means that we can say now that our critical region, we're starting to build it, is equal to x being less than or equal to 1. But of course, there is also the upper tail that we need to consider. So we'll investigate that now. So over here, we'll say upper tail. And we need to do a little bit of working around for the upper tail. It's a bit trickier because we need x to be greater than or equal to some value. Let's call it s. Maybe not s. Let's just go with d. And that again needs to be as close to 0.25 as possible. Now, our calculators don't do this unless you've got maybe the CG50 or CG100, which they can do upper tail calculations. This calculator here will only give you less than or equal to. But what we could do is we could say that if you are greater than or equal to d, what you not are is less than or equal to d minus 1. Okay, so it's 1 minus the probability of being less than or equal to d minus 1, because you're either d and above or you are d minus 1 and below. So you're one of the two, so they must add to 1. Okay, so we can rearrange this by minusing 1 from both sides, which gives minus 0.975. And then after that, we can multiply through by the negative, which if you are doing a less than 2.5% type critical region, then that would actually effectively flip the sign over of the inequality. But because we're doing a closest to the 0.025, it doesn't matter. Okay, great. So now what it means is we are going to go down here and we are going to look for the value which is closest to 97.5%. And we've got two here. We've got this one, or we've got that one. So 97.5 is halfway between these two. Not halfway, but it's in between these two. And in fact, this one is closest to. So therefore, we can say that the probability that x is less than or equal to 9 is approximately 0.9876. So that means that the probability that x is greater than or equal to 10 is 1 minus that. So we can do 1 minus that calculation, because once again, you are either less than or equal to 9 or you're greater than or equal to 10. So you could do 1 minus in order to work out that. And that then is going to be 0.0124. Perfect. Okay, so let's highlight that. So I think we're going to need that for the next part of the question as well. And that means that our critical region is completed by saying that x needs to be greater than or equal to 10. Okay, so we'll box that up in red because that is our final answer to part B. And then part C asks us to find the actual significance level of the test. So the actual significance level is the chance that you are in the critical region. Okay, so the actual sig level is going to be the chance you're in the critical region. So it's going to be these two probabilities added together. Because it's a two-tailed test, you have an upper and a lower tail part of the critical region. So we just need to add those two together to get our actual significance level. Okay, so that's 0.0265. Perfect. And actually, just as a final note, because I know I might get asked this in the question, it doesn't actually ask us to do the test. So I didn't write that H0 probability is equal to 0.35, and therefore H1 the probability, because it's a two-tailed test, is not equal to 0.35. So those are the hypotheses of the test, which you would need to state if you were doing the test. It doesn't actually ask us to do the test. It just says find the critical region for the test. But anyway, probably would have been better. I would just write that anyway. But so yeah, just make sure you always write down the null and alternate hypothesis, just as habit, because you don't want to lose out on a mark on that. Though you would have for this particular question, but as good habit, always write down the null and alternative hypotheses. Okay, we've got the normal distribution, and we've got the weight of Amy's jam has a normal distribution, and we're told we don't know sigma and mu, but we have one bit of information and we have another bit of information. So as always, what I'd recommend doing is drawing out a distribution. So we don't know the mean and we don't know the standard deviation. But what we do know is that if we were to draw it like this, then there's going to be a certain point there, which is actually exactly 388, and that to the left of it has an area of 0.01, and then there's going to be another one here which is 410, and that has an area of 0.0197. Perfect. What we can do next then is we can draw a second distribution below, the standardized distribution. And this distribution we call Z, and it's normally distributed with 1 and 0, and it then allows us to convert between the two. So what we'll do is we draw exactly the same lines on there with exactly the same areas, like so. And then we will go to our calculator to find these Z values. Okay, so the way that we do that is we go into distribution, we go into inverse normal. We want the area, and it always works from left of the line. So left of this line here is an area of 0.001. So we put that in there. And again, because it's standardized, we've got mu as 1, sigma as 1. Sorry, mu as 0, sigma as 1. We press execute, and there we go. There's our Z value. Okay, so we write that down there. That's minus 3.090. And then we need to find the next one. And the area, again, it's the area to the left. Whoops, the area of to the left of this line. So we know the area to the right is this. So the area to the left will be 1 minus this. Like so. Same mu, same sigma. Execute. Great. So that is 2.056. Yeah, perfect. Okay, now the formula that links these two distributions is that Z is equal to X minus mu over sigma. Okay, so we could create two equations because we've got two bits of information that are linked. So we'll start with minus 3.090 is equal to the X, which is 388, minus the mu over sigma, and we can rearrange this by multiplying through by sigma, like so, and then adding on mu, like so. Okay, and then the next bit of information is that the Z of that there is equal to the corresponding X, which is this, again, minus mu over the standard deviation. We can multiply up by sigma like that, and then add the mu over as well. Just do it in one swoop, and that will equal 410. Okay, and then we can solve the simultaneous equations, and I'm just going to do that on my calculator. So I'm just going to go into equation, simultaneous equation, two unknowns, and we have minus 3.090. We've got 1 mu, and we've got 388, and then we've got 2.056 sigma, 1 mu, and 410. Okay, so that gives us an approximate value for the standard deviation. So we'll go 4.275, and then for mu was the next variable, and we'll go 401.2. Okay, perfect. There we go. Okay, next it says that Amy selects 10 jars at random. Find the probability that at least one of these jars contains between 399 grams and 401 grams of jam. Okay, so the clue here is that you are selecting 10 jars at random. That's a fixed number of trials. So that is going to tell us that we need to do some sort of binomial distribution in here. Okay, now, because there are 10 jars happening. Now, the probability of a success, well, a success is being in between 399 and 401. We can use our normal distribution to work out that probability and then put that into the binomial to work out the probability of that happening at least once. Okay, so it's a classic work out the normal and then use it in a binomial afterwards. Okay, so we'll go part B, and we need to use the normal distribution, which we now know has a mean like so, and a standard deviation like this, so the variance is squared. And we need to work out the probability that we are in between, should I say, 399 and 401. Okay, great. So let's go then to distribution. Okay, so let's go to normal CD, because we are, with normal distribution, we always use CD, in fact, never PD. And the lower is 399, and the upper is 401. And we said that mu was 401.2, and sigma was 4.275. Okay, great. So we get 0.1780. Great. Okay, so actually that's not our final answer, of course. That's just a working answer, because now we can use the binomial distribution, and because there are 10 jars, and the chance of an individual jar being inside that range of 399 to 401 is, as we've just proved, 0.780. Now, we were asked for, let's just double check exactly what we're asked for. We want, out of those 10, to have at least one having success, where success is being in between these two. So at least one is one or more, like that, which is also the same as 1 minus the probability of none happening at all. Okay, so we can go to the binomial distribution, binomial PD, because we just need to work out what the chance is of having, whoops, not list, variable. So let's just work out the chance of there being 10. And no, we need 0 out of 10, and we need this to be the chance of success. Great, so that is therefore 1 minus 0.1408. So we can just go back, number 1 minus that answer, and that gives us 0.859 as our final answer. Perfect. Okay. So there's been a lot of rounding in this question. So if you're just slightly different to your final answer, then it'll be absolutely fine. So let's go then on to the next, and we are now looking at what looks to be like a hypothesis test, because we've got it says that the machine is adjusted, and you've got a sample of 25 jars is taken. And it says that the mean amount of these jars is found to be this. Assuming that the standard deviation remains unchanged, test the 5% level whether the mean amount of jam in the jars has decreased. Okay, so let's set up our hypothesis then. So we've got C, we've got H0 is that mu is equal to what it was before, which is 401.2, and we are claiming that that has decreased, so that's our H1. And then a sample mean distribution, we're going to assume H0 is true as always. Now the standard deviation, the variance, should I say, is going to stay the same as well, which is 4.275, I think. Yeah, 4.275. Okay. That needs to be squared. And then also it needs to be divided by the sample size. So it's just something you have to remember, that when you are doing a normal hypothesis test for the mean, you divide the variance by the sample size, which means the new standard deviation becomes 4.275 over the square root of 25, because that's what's going to go into your calculator. Okay, so we now need to work out a probability, and because it says that we found the mean to be 399.4, we need to see how likely that was to have happened with the old mean in place. So assuming H0 is true. So we say, well, what was the chance that we had a mean of 399.4 or smaller, because that would only strengthen the claim that the overall mean has decreased. So let's work out that probability, and then we could compare it to the 5%. Okay, so we're going to go to our calculator, and we're going to go to normal CD, and we're going to say lower is just a really large negative number, and the upper, the largest it could be, is 399.4. We're going to keep the mean the same. Now that standard deviation, we're going to need to divide by the square root of 25, which is 5, of course. Okay, great. So there we go. There's our probability, 0.0176. And that is most definitely bigger than the 5% significance level. Okay, so that means that we are going to reject H0, because this is inside the critical region. So let me write that down. And there we go. So we reject H0. There is sufficient evidence at the 5% level of significance to suggest that the mean amount of jam in the jars has decreased. Remember, as always, make sure you link it back to the context of the question. So important to get that final conclusion mark. Question 7, and it says that we've got the proportion of plates that are flawed is 45%. and they occur independently, and we've got a sample of 10, so I'm thinking binomial because that's a fixed number of trials. So we say X is binomially distributed, there are 10 trials, and the probability of success, well, in this case being flawed, is 0.45. Okay, and then for the first part, it says to find the probability that fewer than 2 flawed plates. Fewer than 2 means less than 2, which means X is less than or equal to 1. Yes. Okay, I always find that quite difficult with the wording, but make sure you try and read it as slowly and as carefully as possible. So you get 1, you got 10, and you got 0.45. Okay, and that gives us 0.0233. Okay, there we go. Now next it says at least 6. Oh gosh, what does that mean? So the probability of at least 6 means, yeah, the smallest you have is 6, so it is 6 or more, which is 1 minus the probability that X is less than or equal to 5. Yes, because if you're 6 or more, then you're not 5 or less. And our calculators do less than or equal to. So we need to convert it into a less than or equal to, like we've done there. Okay, so this is 1 minus 0.7384. Okay, which is 0.2616. Perfect. Okay, right, now onto the tricky part of the question, where we've got George believes that the proportion of flawed plates is not 45%. To assess his belief, he takes a random sample of 120 plates. The random variable f represents the number of flawed plates found in the sample. Using a normal approximation, find the maximum number of plates C and the minimum number of plates D such that the probability that f is less than or equal to C is less than or equal to 5%, and vice versa. The upper tail also needs to be less than or equal to 5%, where f has given us that. Okay, so the clue here is obviously the normal approximation that they're telling us to do. We know that f is binomially distributed 120 0.45. So let's use y is going to be an approximated normal distribution. And remember that the mean when you approximate the binomial using the normal is NP, and the variance is NP 1 minus P. So this will mean, so we'll have to do 120 multiplied by 0.45 to get 54. That's NP. And then NP times by 1 minus P, or 1 minus P is 0.55. So that gives us 29.7. Okay, remember that's the variance, not the standard deviation. Okay, so now let's look at the upper tail. Sorry, the lower tail first, because that's always the easiest one to calculate. And let's just quickly draw a little sketch as well of what this normal distribution will look like. Something like this. Okay, now we are looking for an area of 5%. So it'll look like that. So that area will be 0.05 there. Perfect. Okay, now very importantly here is the continuity correction. Whenever you do normal approximation, you have to think about the continuity correction, because we are looking for the probability that f is less than or equal to c, which is approximately using the normal distribution. First off, we can write less than here, because it doesn't matter when you use the normal distribution whether it's less than or equal to, because it's continuous, and so it doesn't, if it's equal to a particular value that has such a small probability that it's completely negligible. So we can always just write a less than sign here rather than a less than or equal to. Now, with the continuity correction, let's say, for example, f, we were looking for less than or equal to 5. Then when you approximate that using y, you would be less than 5.5, because 5.5 is the largest number that technically still rounds down to 5. And f is discrete, which means in this case it can only take whole numbers, whereas y is continuous, so it can take decimal numbers, and 5.5 is the largest decimal number which still rounds down to 5, and 5 is acceptable because we are less than or equal to 5. So for this case, we're going to say c plus that 0.5, okay, which makes it kind of the upper bound if you are using decimals. Okay, so that needs to be less than or equal to, as it says in the question, that 5%. Okay. Now what we can do on our calculator, we can find the value from this normal distribution that gives us exactly 5%. So let's do that. So let's go into inverse normal, and let's go to area. We want, yeah, perfect. We want this to be 0.05. That's the area we want, as you can see here. And the mean is 54, as we worked out. And the standard deviation is the square root of 29.7, which was the variance we worked out. So if we press execute and press execute again, we get that if this was an equals to, if this right here was equals, then it would mean that c plus 0.5 would equal 45.03. But we don't want it to equal 0.05. We want it to be less than or equal to 0.05. So if we've seen here that this is c plus 0.5 on this graph, anything to the left of c plus 0.5 will be inside this region, which will have a probability which is less than 5%. So really, we just need this to be the c plus 0.5 to be less than 45.03 in order for this to work, because then that would mean it would be to the left of this point here, which would mean it would have a probability which is less than 5%. Okay, great. So that means that c is less than, take away the 0.5, so 44.53. And because we are looking for c being the maximum number of plates, and c needs to be smaller than 44.5, then c, the smallest, the maximum number you can use is 44. So c is 44. Okay, right, now we need to do that all over again, but now for the upper tail, which is even more tricky. Okay, so we'll start down here, and we'll say upper tail, and we'll do our normal distribution curve. And again, like that. And this time we've got a line here, okay, and we're saying that the upper tail needs to be, again, 5% or greater than 5%. So it needs to be in that region, in that red region, because it says that we need to find a d value such that it's greater than or equal to d. And again, that's going to give us a value, an area of 5%. Okay, so we're going to do the same thing as we did before. We're going to say the probability that f is greater than or equal to d is approximately, when using the normal, well, again, if you had like f was greater than or equal to 6, let's say, then you would say that we would have the normal distribution being greater than 5.5. And that's because 5.5 is the lowest possible value, which will still round up and be inside the set of numbers that we are looking for, which are 6 or more. So 5.5 is the smallest you can get, but it will still round up into 6. So we're going to say that y is greater than 5. Sorry, we're going to say it's d minus 0.5. Okay, because you have to take off 0.5 like we did here. When we were 6, we took off 0.5 to get 5.5. Okay. So that needs to be less than or equal to 5%. So we can go to our inverse normal again. Now, remember our calculators always do area to the left. So for the upper tail, we do area 1 minus 0.05. Same mean, same standard deviation. Oh no, I've just got rid of the standard deviation. That's so annoying. It was 29.7 rooted. Execute. Great. So this tells me that D minus 0.5, if it was, again, exactly equal to 5%, then it would equal 62.96. But we don't want it to be exactly bang on 5%. We want it to be 5% or less, which means we need to be in this region here. And anywhere in this red region, well, the value for y will be greater than this D minus 0.5. So we're saying D minus 0.5 needs to be greater than 62.96. So D needs to be greater than 63.46. And again, if we go up here, it says that it's the minimum number of plates for D. So the smallest number we could possibly get, but still being greater than 63.46, would be 64. Wowza, what a tricky question that was, eh? But that's done. Phew. Okay, we can move on to mechanics. Yes, we're on to mechanics. Yay! We have constant acceleration, and we have velocity is this when t is 0. So that's the initial velocity. So we can do a suvat given that we are in constant velocity. So we can say s, we can say u, we can say v, we can say a, and we can say t. Now a is minus 2i plus 3j, and u is 10i plus 4j. Because that's when t is 0, that's the velocity. It says find the direction of motion. So direction of motion means we need to work out the velocity vector. When t equals 6, giving your answer as a bearing to the nearest degree. Okay, no problem. Well, we're looking for the velocity, and we know t is equal to 6. So the suvat that does not include s is v equals u plus at. So v is equal to u, which is, now, do I use i's and j's or do I use columns? I prefer i's and j's, but I know most just prefer columns. So I'm just going to go with columns, even though I don't like it. Plus the acceleration, which is minus 2, 3, and then times that by t, which is 6. Okay, so great. Let's just simplify this so I don't want to make a mistake, because that gives us minus 12 and that gives us 18. Okay, so the velocity therefore is equal to minus 2, and 4 plus 18 is 22. Okay, great. So it'd be a good idea just to draw a little sketch of what's happening here. So if you've got a velocity like so, then that means you've got going 2 in the I direction, and you've got it going 22 in the J direction. So draw a little velocity like vector, like so, and then connect it up to see what the direction of motion would be. So that would be minus 2 down there. Okay, and then because it's asking for a bearing, it's always a good idea to draw a north line in. So from where it's starting to where it's going. So that would be our north line. Okay, so if we, the angle that we want to work out Well, this angle is going to be super useful, of course. Let's call that theta. We can find that out, and then we can work out the bearing relatively straightforward from that. So we can say that clearly you can see tan theta is equal to the opposite, which is 22, and the adjacent is 2. I know it's -2 written there, but in terms of the actual triangle, obviously triangles have only positive side length, so which means the side length of that triangle as 2. Why did I drew it as a vector? What is that about? Sorry. Of course, that means a fraction. Okay, so therefore theta is equal to tan inverse of 22 over 2. So we could do that on our calculator. Okay, there we go. So put that in the calculator, and that gives us an angle of 84.8. Now the bearing is always measured from north, going clockwise around until you hit the line. So that angle in there is going to be our bearing, and that will be 270 plus theta. So that is 354.8, and to the nearest degree, that's 355. And that will be our final answer for the direction of motion. Perfect. Okay, so on to part B, and it says find the value of t when P is moving northeast. Okay, well, northeast is this direction. And if you're moving northeast, then your I component, let's say it's 5, must match exactly to your J component in order to send it off perfectly in that northeasterly direction. So it means the I component of the velocity needs to be the same as the J component of the velocity. Okay, so for part B, we can say that VI needs to equal VJ. And if we look at our velocity equation again, we have that velocity is equal to U plus AT. And velocity is therefore equal to 10, 4 plus -2, 3 t. So we could say that the v in the I direction is the 10 here and then -2t, and that's equal to the v in the j direction, which is 4 plus 3t, like so. So that is the equation that we need to solve. Right, so just moved it around there to grab some more space. But yeah, we're solving the same equation. So we're going to -4 to both sides, and we're going to add 2t to both sides. And then we're going to divide through by 5 to get t is equal to 1.2 seconds for our final answer. Okay, question number 9. And we have that we've got the velocity equation and its variable acceleration, because you can see that the velocity is in terms of t. When you differentiate that, you will get the acceleration, which will still be in terms of t. So it's variable acceleration. So we're going to be doing integration and differentiation here. So it says find the acceleration at the instant when t is equal to 0. So the acceleration is the derivative of the velocity. Okay, so I'm going to differentiate the i's first to get 6t. So that's the i's. And then differentiate the j's next just to get 2. Because, yeah, 2t differentiates to just 2, and then -4 is a constant, so that differentiates to 0. Okay, and now we need to find the acceleration in the instant when t is equal to 0. So when t is equal to 0, well, this term here will go to 0, but 2j will stay, so a is equal to 2j. Okay, great. Now, part B. Find the exact speed of P at the time when P is moving in the direction vector 11i plus j for the second time. Wowzer. Okay, so if it's moving in the direction vector like this, it's 11i plus 1j. So that's the direction it's going in. So what I like to do is work out essentially its gradient. Okay, because the gradient will be the change in the j's over the change in the i's. So it's like 1 over 11. You can imagine that the direction of motion is like a gradient. So we need that to be the same. So we need to work out the direction of motion, which actually we have already, because the direction of motion is the velocity. The velocity tells us which way it's going, and we have the velocity equation. So we just need to say for the velocity equation that Vj divided by Vi will be the gradient, because it's the velocity in the j direction divided by the velocity in the I direction is going to be the gradient, and we want that to equal 1 over 11 because we want it to have the same direction gradient as the vector which we're told here. Okay, so the Vj was 2t minus 4 was the j component of the velocity, and the I component was 3t squared minus 4. Okay, that just comes from up here. And we want that to equal 1 over 11. So we just multiply through. Whoops. So we multiply up by 11 to get that denominator become 11 times bigger. And then we multiply the denominator here up, times it by 1. Just gives us 3t squared minus 4. So let's set it equal to 0 because this is a quadratic we can solve. So 3t squared minus 22t and then plus 40. Okay, perfect. Let's solve that. Right, so no marks for solving quadratics, so just going to whack it in the old calculatrice. And looks like we're going to end up with 4 and 10 over 3, which is, less than 4. So we get t is equal to 4, or t is equal to 10 over 3. Now, if we go up here, reminder, it says that we want it to be in there for the second time. So because we want it for the second time, well, t equals 4 is after 10 over 3, which is obviously the first time. So t equals 4 is the second time. Okay, so let's find the velocity first. So the velocity, and let's just sub in t equals 4 into the velocity equation, which is up here. So it's going to be 3 times 4 squared minus 4. That's the I direction. And then the j direction is 2 times 4 minus 4. So the velocity will be 16, 48, 44i. And then plus 8 minus 4 is 4j. Okay. And then the speed is equal to the magnitude of the velocity. So that means that we square root the two components squared and added together. Like so. It does say the exact speed. So I will just need to do 44 squared plus 4 squared, and then I will square root that answer to get 4 root 122 for our final answer. Bosh. Okay, now on to part C, and it says show that P never returns to the origin. So if we are talking about returning to the origin, then it means the position of the object, and that means that we need to integrate the velocity to get the position. Also note that the condition that we're told is that when t is 0, it's at the origin. So that's helpful because it means that when we do integrate, the constant that we get will be 0. And I'll show you why as well. Okay, so for part C, we can say that we need to integrate the velocity with respect to time. That's going to give us the position. And that means that we're going to be integrating 3t squared minus 4 is the I. I know I said in the previous question I was going to do columns, and I've just reverted back to I's and J's, but I just forgot. Sorry. Anyway, you could do with I's and J's. So to integrate this, 3t squared integrates to t cubed, and minus 4 integrates to minus 4t. Okay, and then integrating this, 2t integrates to t squared, minus 4 integrates to minus 4t, and then again plus c. But we know that this is equal to the position. The position is 0 when t is 0, which means therefore c must also be 0. So we could just say c is 0, so that's great. Okay, now if it's going to return to the origin, then it's going to need the I and j to be equal to 0 at the same time. So if we are going to return to origin, then the position in the I needs to equal 0, and the position in the j needs to equal 0 at the same time. Okay, at the same time. Okay, so let's find the times when each of these do equal 0. So Ri equals 0 means that t cubed minus 4t equals 0. We can factorize out a t, like so. And this gives us that t equals 0 or t equals plus minus 2. Okay, and then what about Rj equaling 0? Well, that happens if t squared minus 4t equals 0. Factorize out a t, we get t minus 4. t minus 4 equals 0, which means that t equals 0 or t equals 4. Okay, so they don't match up. There is no time when both Ri and Rj are equal to 0. And as always, we're going to want to write a little conclusion there. So I've said the only common value is t equals 0. Therefore, after it leaves the origin, the particle never returns back to the origin because there's no time in which both the position in the I and the j are 0. Question 10, projectiles. And it says that we've got the initial velocity is 4i plus 7j. The particle moves freely under gravity and hits the ground at B, so it's just like a perfect up and down. Find the distance AB. Okay, so for any projectile question, I will always start by drawing or setting up two suvats. So one for the horizontal, so we do S, U, V, A, and T, and one for the vertical. We do S, U, V, A, and T. So horizontal has 0 acceleration, and vertical has minus 9.8. We know the initial in the horizontal is 4i, so just 4, and in the vertical it is 7. And that's about all we know, really. So if we are looking at the point B, so this grid here that we're doing, these two suvats are going to be talking about the journey from A to B. So what we do know is that at the end of the journey, the displacement in the vertical is 0 because it started on the ground and it's going to end on the ground. Okay, so we can use that information to work out the time over here. So we can say S is equal to ut plus a half at squared, because that's the suvat equation that doesn't involve V. We can say 0, and we can say U is 7. We can say T, we don't know. we can say a half of a is minus 4.9, and that's t squared. Okay, great. We can just factorize out a t to get 7 minus 4.9 t. So we either have t as 0, which is of course true because we know it starts with 0 displacement, but the one we're interested in is this one here, and to solve that bracket would give us 7 over 4.9, which perhaps we'll calculate that into a more nicer fraction. 10 over 7, great. Okay, so now we can use the horizontal because now we know the time. So we can say, using the horizontal, again, we're not using v here, so let's just grab some space here. Let's move you over. Okay, so we can say s equals ut plus a half at squared. So s is equal to u, which is 7. T we now know is 10 over 7. And because in the horizontal a is 0, the half at squared is just 0. So this just gives us 10, and that will be in meters. So 10 meters is our answer there. Okay, so we use the vertical here, and then we use the horizontal here. Great. Now it says that the speed of p is less than 5 meters per second for an interval of length t seconds. Find the value of t. Okay. Well, what we're going to need to do is work out the speed. So we're going to need to use our equations here, but we're going to need to use v. Okay, so we know that v is equal to u plus at. And this is good. That's all we need, because we're looking for the velocity. And let's do it again, split it up into the horizontal first. We've got v is equal to u, which is 4. And then there's 0a. A is 0. So v is just equal to 4 in the horizontal. And in the vertical, v is equal to 7 for u plus minus 9.8 t. Okay, so those are our two velocity equations. And then moving over, it's talking not about velocity though, it's talking about speed. So it wants the speed to be less than. And we know, of course, that the speed is the magnitude of the velocity. And we want that to be less than 5. And how do we work out the magnitude? We take the square root of the components, which is the horizontal component of velocity squared plus the vertical component of the velocity squared, and that needs to be less than 5. So from here, we're just going to expand the brackets and square both sides. So that's going to give us 16 plus 49, and then we will get 7 times 9.8 times by 2. So that will give us minus 137.2 t, and then we'll get also 9.8 squared t squared. So 9.8 times 9.8 gives us this. Okay, and that will be t squared, and that needs to be less than, and I've squared both sides to get rid of the square root, so that is 25. Okay, great. So now we can collect up this quadratic like so. And we've got 16 plus 49, and then we're going to minus the 25. So we've got 16 plus 49, and then we're going to minus the 25. So we get 40. So that's plus 40, and that's going to be less than 0. Okay, great. So now we can just go into our quadratic inequality solver, like so. And we can do a quadratic, and we want it to be less than 0. So that one. And we'll just type in our numbers. Great. So it's in between those. Well, why not? Let's just leave it like that. That sounds great. Okay, so that means that we are in between here and here for the amount of time that the object has a speed of less than 5. But the question does say it's the so t is the interval length. Okay, so it's not that t, capital T, actually is between there and there. Capital T is the interval length. So that means that capital T is the end of the interval minus the start of the interval to give us the amount of time that the object actually is moving with a speed of less than 5. So that is our final answer, and that is obviously in seconds. Okay, so the question says, at the instant when the direction of motion is perpendicular to the initial direction of motion of P, the particle is h above the ground, find h. Okay, so initially you can see here that it's going in that direction, which means that it's going along 4 in the I, and it's going up 7 in the J. Okay. So we could say the gradient of that is 7 over 4. Now, if it's going perpendicular to that, then the gradient of the line perpendicular, i.e. the direction of motion, will be minus 4 over 7, because it's a negative reciprocal, as we know, perpendicular gradients. Okay, so that means that the change in the y could be minus 4, like something like this, and the change in the x, or the j direction, could be something like 7. But it doesn't necessarily mean, it doesn't have to be minus 4 and 7, of course. It just has to be within that ratio. So we know that the j, whatever the j is, speed, divided by the I, it needs to be in that ratio. So we have the j divided by the I, so the velocity in the j divided by the velocity in the I must equal minus 4 over 7. Okay, great. So let's go down and let's use the fact that that is the case. So for part C, we're going to have that the velocity in the j divided by the velocity in the I must equal minus 4 over 7. The velocity in the j, again, we're going to use v is equal to u plus at. So the velocity in the j, well, initially the velocity in the j was 7, and we know the acceleration in the j is minus 9.8. So it's 7 minus 9.8 t, and the velocity in the I was just 4 initially, and again, because acceleration in the I direction is 0, so it's just 4. Okay, great. So let's use this, and let's say that it's going to be 7 minus 9.8 t divided by 4 is going to equal minus 4 over 7. Let's cross multiply. So times the top, this denominator here, the one on the left, by 7. So we get 9.8 multiplied by 7 gives us 68.6 t. and then times up by the 4 gives us minus 16. Okay, let's add 16 to both sides to get 65, and let's move that over there. Okay, and then we can find t by dividing through by this, so we can do 65 divided by the answer, and we get 0.9475. Okay, great. Now the question doesn't actually ask us for the time. It actually asks us for the value of h, so the distance, so the height above the ground. So that means we're going to need to use a vertical suvat. So let's write out our suvat again. So the displacement is what we've been referred to as the height, so h. Initially it was going 7, and the acceleration is always minus 9.8 in the vertical, and we now know the time. Great, so we can bin off v, and we can say that s is equal to ut plus a half at squared. S is equal to h, u is 7. We're going to use this time, and then a half of a is minus 4.9, and again we're going to use this time squared to find h, and so that's going to give us 7 answer button minus 4.9 answer button squared equals, great, so that's 2.233, and that needs to be rounded, doesn't it? And I've just have a revelation here that I must give my answers to 2 decimal places. No, 2 significant figures, at most 3, because we've been using G. And I can see up here, I didn't do that. Whoops. But luckily, I've just spotted that in the nick of time. Because on the front cover, it does say, if you are using G in your calculations, you should give your answer to 2 decimal places. And I think you just about get away with it if you do 3. But I know for a fact you'll get it wrong if you do 4 not decimal places, significant figures. Okay, so I'm going to go over 2 significant figures here because that is what's recommended. And I know that you can get marked down if you don't abide by that rule. Okay, there we go. Okay, so on to forces, dynamics. We've got a rough plane inclined at 30 degrees to the horizontal, and a particle of mass 0.5. So it's all about drawing a good force diagram. So if it's got a mass of 0.5 kilograms, then the weight is 0.5 times g. And we're always going to want to resolve those forces. So this is going to be the force which is acting, the component of the force which is perpendicular to the slope. And whenever you draw a weight force going directly down and then the perpendicular component, that angle in there is always the same as the slope. So 30 degrees, which means this force here is 0.5 g, and it's cos of 30 because it is adjacent to the angle 30. And then we can also draw this force on here like so, and this one will be 0.5 g sine of 30 because it is opposite the angle 30. Okay, now we've also got this force of 5 newtons, so we can again start at the start of the force and draw a perpendicular to the slope component, and then we can connect that up to a parallel to the slope component like so. Now this force is also, this angle in here is also the same as the slope. You can see that more clearly if you were to draw like a Z on here. So it's alternate angles. So both of those angles are 30. So this green angle force coming down is 5 newtons, and then we need to multiply by sine of 30 because the green side is opposite the angle 30. And then on here, the red one here is going to be 5 cos 30, and that's because it is adjacent to the angle 30 there. Great. A few more forces to do, and that is the reactional force, which always happens, which is always perpendicular to the slope. Sorry, I didn't know why it just drew an arrow like that. I didn't even know it could do that. Okay, there we go. I'll draw my own arrow, thank you. And that is R, we'll call that the reactional force. And then one more force, and that is the frictional force. And we don't know necessarily which way it is acting. We need to read a bit more information. It says it's held at rest on the plane by a horizontal force. The force acts vertical to plane. Yeah, bloody, 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 blah. Here we go. The particle is on the point of moving up the plane. So it's just about to move up the plane, which means friction is going to be acting against that possible motion. So it's going to be pushing it down the slope. So that's frictional force. We'll call it FR. Okay, so that's our force diagram. Always important to do that first. And now we can start answering the question. And it says, find the magnitude of the reactional force of the plane on P. So we are going to be looking at all of the forces acting perpendicular to the slope. Okay, so the perpendicular forces, and going upwards, you could say is R, and that's balanced with the ones that are going down, which are 5 sine 30 and 0.5 G cos 30. So let's find that. Okay, so I'll just put that directly into my calculator, and we've got 6.74 4, and once again we're using G, so we're going to give that to two significant figures and just use 6, 7. Hey, still cool, still funny? No, maybe, I don't know. Okay, actually let's write also the unit as well, of course, which is newtons. Okay, now it says find the coefficient of friction between P and the plane. Okay, so now we are looking parallel to the slope, clearly, because that's where the frictional force is going to be. So now let's resolve parallel to the slope. Okay, so going up the slope is 5 cos 30, and then going down the slope is the frictional force and 0.5 G sine 30. Okay, so that means the frictional force is equal to 5 cos 30 minus 0.5 G sine 30. Now, because it's in limiting equilibrium, which means it's just on the point of moving up the plane, it means the frictional force is equal to mu r. Okay, so therefore we can just divide through by r to get mu. So we need to type this into our calculator. Divided through by r, and we know r is roughly 6.7. Okay, we can use the exact value on our calculator as I was just about to do. Okay, so I'll just put that into the calculator, and we've got 2.788, which is approximately, again, I'm going to use 2 decimal places, or 2 significant figures, to give my final answer for mu. Perfect. Okay, part C. It says the force of magnitude 5n is now removed and P accelerates from rest down the plane. Find the speed of P after it's traveled 3 meters down the plane. Okay, so I'm going to need to draw a new diagram. Okay, so we need to remove the force of 5. So we'll do that. And it's important to note that when you remove a force from a force diagram, it's going to have an impact on some of the other forces, particularly in this case, the reactional force will change. So we need to recalculate the reactional force, because then we'll use that to recalculate the frictional force. So if we now look again perpendicular to the slope, we have the R going up needs to balance with only now that 0.5 g cos 30. Okay, so that's the only thing which is balancing with R. So R has changed. So we'll work out what that is. Like so. Okay, so that's approximately 4.24. Let's say 4. Okay, so now the frictional force is again equal to mu r. So we can work out the new frictional force. So we can times that by the coefficient of friction, which we'll just use that exact value, well, not exact value, but a good degree of accuracy there. Okay, so that's the new frictional force, like so. Also, now that the object is going to be accelerating down the slope, like so, it means that friction is actually going to be working in the opposite direction. So we need to get rid of that. Well, not get rid of it, but we need to turn it around. So it's going to be opposing the motion. Okay, so friction is going to be acting in that direction. Okay, so now we can do a forces equation for down the slope. Okay, so down the slope now, we have that 0.5 g sine 30 is working in the direction of motion, whereas the frictional force is working against, and that's all equal to the mass of the object times by the acceleration. Great, so we can rearrange this and we can work out the acceleration. Okay, so I've just put in my calculator this 0.5 g sine 30 minus the 1.183 to get this. So then I'm going to just times that by 2, and that's going to give me the acceleration down the slope, which is 2.53. Let's say, yeah, that'll do. Perfect. Okay, that's the acceleration down the slope. Okay, so now to find the speed of the object, we're going to need to do a suvat because it has constant acceleration. And we know that acceleration now is 2.53. It said that initially it was at rest. It says that it's going to travel 3 meters, and we're working or looking to find the speed. So we don't need t. So we'll be doing v squared is equal to u squared plus 2as. So we'll get v squared is equal to, well, u is 0, so it's just 2 times a, and then times by s. So that is going to give us v squared is equal to, it's just times this by 2 and 3, which is 6. So 15.2. So v is equal to the square root of 15.2, which is approximately, and again, sticking to that theme of making sure we're giving our final answers to 2 significant figures when g is involved, we get 3.9, and that will be meters per second to the -1. Perfect. Okay, got a beast question here, connected particles. And we're going to start off, as always, by drawing on our forces. So we have the weight force here will be 4G. And then there'll be tension holding the object up. And then over here, we'll have a weight force come down, where it will be 2G. And then we'll need to do our components. So we'll draw U coming down like that. And U will be, the angle will be the same as the slope, as it always is. So in there, that is alpha. And then we'll also, that means that we can say that the green one is going to be 2G cos of alpha. And the red one, because it is opposite the angle alpha, is 2G sine of alpha. Okay. And it does say it's a rough plane. So it's going to be useful to know the reactional force so that we can calculate friction. So we'll just call that R going up. And well, there's going to be tension in the string as well. The tension is going to be pulling that object upwards, like so. So the tensions are always acting sort of inwards. Okay, that sounds good. Now we do also have that tan of alpha is 3/4. So we draw a little triangle like this. We put alpha in the corner. We say opposite over adjacent, 3/4 is tan. And by Pythagoras, that's 5. So that then allows us to work out cos alpha and sine alpha. Okay. We also know the coefficient of friction. Mu is equal to 1/4. That's going to be useful. It says the system is released from rest with the string taut and B descends, right? That's what I was looking for. That tells us the direction of the acceleration. So if B descends, it means that one is going down like that. And because it's a connected object, it means this one must be going up like that by the same, obviously the same acceleration because they're connected. So tension there. And then we've also got friction finally, which is going to be acting down the slope because it's going to be opposing the motion, and that object is going to be accelerating up the slope. So we've got the frictional force in there, and now we can start answering the question. Okay, so here's the diagram, and we've been asked to work out the tension. Now, the first one we're going to do is, well, we can resolve perpendicular to the slope, because you look at the green forces there, which tells you that they must be balanced, because obviously the object isn't just jumping off the slope and accelerating up. So they must be balanced. So we can say that R is equal to 2G cos alpha, and cos alpha from our triangle is the adjacent over the hypotenuse. So that's 8/5G. So now we know R, we also know friction, because the frictional force is equal to mu R, because it's accelerating, so friction is going to be working at its maximum. So that's equal to 1/4 is mu times by 8/5G. So that will be 2/5G. Okay, great. So now we can start doing our equations of motion for each object. So let's start with A. So for A, we have going up the slope in the direction of motion, the tension, and then going down, we've got minus 2G sine alpha, and we've got minus the frictional force. And that's going to therefore equal the mass, which is 2 times by the acceleration. Now we can simplify this a little bit, because 2G sine alpha is 2G sine alpha is going to be 3/5. And then the frictional force we already know is 2/5G. And that's equal to 2A. So we've got 2g times 3/5 minus 2/5 g. So that's 6/5 minus 2/5. That's going to give us minus 8/5 g. It's equal to 2a, like so. Okay, that's great. Right, let's box that up, and then let's work out the equation of motion for B. Okay, so B is accelerated downwards. So we'll say for B, we have 4g acting in the direction of its motion, and we've got t acting against it. So 4g minus t is equal to its mass times by acceleration. Okay, that's that one done. And we'll box that one up as well. And those are our two equations of motion. Now, I'm just going to add those two together because it's just a nice and easy way of solving the simultaneous equations. It will find A, and I know we're trying to find T in this question, but we're probably going to need to use A at some point anyway. And adding them together, the T's will cancel. So we'll have minus 8/5 g, and then plus 4g. So that gives us a total of 12/5 g on that side. And then when we add the two right-hand sides, we get 6a, which means that a is equal to, divide both sides by 6, 2/5 g. Okay, great. So then we can substitute back into, let's say this one here, because t must equal 2a plus 8/5 g, just rearranging that first equation there. So t is equal to, now 2 lots of a is going to be 4/5 g plus 8/5 g is going to give us a total of 12/5 g. Okay, perfect. So let's actually, well, there you go, 12/5 is there, times it by 9.8, and we get this. So that is approximately 23.52. Well, it's actually equal to 23.52, and we'll say approximately that's 24 newtons, sticking with the theme that we're going to give our final answer to two significant figures, given that G is involved. Okay, great. Right. Okay, onwards to part B. And it says, on hitting the ground, B immediately comes to rest. Given that A comes to rest before reaching the pulley, find in terms of H the range of possible values of D. Okay. So we, again, looking at the diagram, this object here is going to hit the floor. And once it's hit the floor, the object here will have moved the same distance, h, along the ramp. And then when it's hit the floor, the string will become slack, which means the tension will be released. So there'll be a change in the forces, thus a change in the acceleration. And then it will have a certain distance left to travel. And we want to make sure that distance is not more than d, because it says that it's not going to hit the pulley. So we need to consider whatever that distance will be. Okay, so I think I'm actually going to need to draw another diagram, just so we can be absolutely clear what's going to happen here. Okay, so we've got the pulley there, and it's going to come off here, and it's going to go along here. Okay, so let's find, let's do a Suvat equation. because the red object is going to travel h downwards, and therefore the green object is going to travel h upwards. And then we're going to get to another stage. But let's work out the speed at which it will be traveling once it gets to this position here. Let's call it the purple position. So it would have traveled a distance of h. We know initially it's been released from rest. We know that the acceleration, we have that, it's here. It's 2/5 g. And what we want to work out is the velocity, because it's important to know that, because that's going to be the initial velocity of the second part of its journey when the acceleration will change because the string has become slack. So the suvat without a t is v squared equals u squared plus 2as. So the velocity is what we're looking for. U is 0. It's 2 times by the acceleration times by the distance, which is h. So v squared is going to equal, so let's do that calculation. So that is 2 times 2/5 times 9.8. It's going to give us this. So so the velocity at the moment when the string becomes slack is this. Okay. Now, for the next part of the journey, we need to recalculate the forces because the string has become slack. So the string becomes slack. So the forces that we have acting, well, there's no tension anymore. There's still a weight force and there's still a frictional force. Okay, so the object, let's call it the purple dot now. The equation of motion for that is that we have the weight force, so minus 2g sine alpha, and minus the frictional force, which we worked out was 2/5 g from here. So minus 2/5 g. That will equal the mass of the object, which is 2, times by the new acceleration. Okay, so we could do minus 2 times by g times by sine of alpha was 3/5. So that's 3/5. And then minus 2/5 of g. Okay, and then we need to divide that by 2, and that'll give us the acceleration. Oh, look at that, how bizarre. Right, so the acceleration is minus 7.84. Okay, so we had to do a new calculation because the forces had changed. So now we could do this suvat. The distance is what we need to work out. And we need the initial velocity, again, because this is now a suvat at where the string becomes slack. So it's going to take the speed that it had in the first part of the journey, and that becomes the initial velocity for the second part. We want this object to come to a stop, so we want the velocity to equal 0, and we now know that the new acceleration for this second part of the journey is equal to that. Okay, so let's just draw a line here so it's nice and clear that we've got first half of the journey on the left, and now this is the second part of the journey. Okay, so again, I'm not too fussed about t, so we're going to be using v squared is equal to u squared plus 2as. Okay, so we get 0 is equal to, now when we square u, we get 7.84 h, and then we are going to times this by 2. Okay, so that's minus 15.86 s, which means the distance traveled in this second part of the journey is going to be the 7.84 divided h divided by 15.68, which gives us a half. So it's just going to be a half h. Okay, great. So that means that the second part of the journey is going to travel a half h. Now, all we know, because the question does ask in a strange way, find in terms of h the range of possible values of d. Well, the only condition that we have on d, which is the whole distance from the start to the pulley, is that the object does not hit the pulley. So that means that how much it travels, which is 1.5 h, needs to be less than the distance d. So d is actually greater than h plus a half h. So final answer is that d is greater than 3/2 h, because d must be longer than that distance in order for it to avoid the object hitting the pulley. Final question, and it's another tough one. So we have a uniform rod, and it has a weight W, so it's 4a long, which means that because it's uniform, W, the weight will act at its center, so 2a along. So we'll call that W. It's the weight, so we don't need to times it by g, because it's the weight, not the mass. And that distance there is 2a. So I'll just write that on as well. 2a is that distance. Okay, great. And then it says that a particle of weight kW is attached at B. Okay, so down here, this is a weight of kW is attached at B. And we also know that it rests on a peg at C. Right, so at C, because it's actually resting on something, that means we can put a reactional force, because we are looking at all the forces that are acting on the ladder, or the rod actually. So because it's resting on something, that gives it support. So we're going to put a reactional force at C. Now, I know a lot of people ask me, probably the biggest question I get asked in the comments section is on mechanics questions, and it's asking, why is there no reaction force at B, for example? Well, because the reaction force only happens when a ladder or a rod or whatever it is actually resting on something. It's being supported by something. In this case, it's also being supported by the ground. So there's a reaction force there. If you've just got something hanging off of a ladder, that's not giving it support. So there's not going to be a reaction force at B. Okay, I'm going to call this reaction force R, and I'm just going to call this one N for no particular reason. Okay, now we're also going to want to do the components of all of these forces, because when we're using moments, we need forces that are perpendicular to the ladder. So I want to find the component of that force, and that will be W cos of alpha. And that's because this angle in here is always the angle of the slope, and the component, the red one, is next to the angle, it's adjacent to it, so we get the cosine component. And same for this one as well. We'll do that in exactly the same way. This is kW weight, and that's cosine alpha. And that is because this angle in here is alpha. Now, we could also put these components on, but in fact, we don't actually need the components of the weight going down the slope. It's actually, so again, it's not a slope. It is actually, it's a rod. So we don't actually need those components for a moment's question like this. So I'm not going to bother putting them on. Now, there are other things that we need to do actually, and that is to find the vertical and horizontal component of this perpendicular force, because that's going to be very helpful. So pick a different color. Let's do purple. So that purple is going to go up there, like so. And then one more color. Let's do light blue. That's going to come across, like so. So we're going to have those forces there. Now, it's a bit trickier to work out where the angle alpha is here. But what we can do to make it easier is we can say that this angle in here is 90 minus alpha. So this angle in here is 90 minus alpha. So this angle here itself is alpha. Okay. So that's helpful. So now we can label up the purple force component, and that is going to be N cos of alpha, because it's adjacent to alpha. And this here is going to be N sine of alpha, because it is opposite the angle alpha. And then finally, we do have that it is on a rough horizontal ground. And this looks to me like this rod is wanting to slip outwards like that. So we need to put a frictional force on, and let's have it going this way, like so. Okay, so those are all the forces that I think I'm going to need. So now let's answer the question. Okay, so the first question says, give a reason why the force acting on the rod at C is perpendicular to the rod. So that is what the force that we've called N here. Why is it acting perpendicularly? And the answer to that is that the peg is smooth. So there is no friction at C, which means that there's no forces acting parallel to the rod going across like that, because C is smooth. So all of the forces acting only perpendicularly to the rod. Okay, perfect. So that's part A. Let's move on to part B now. And part B says, show that the magnitude of the force acting on the rod at C. So we're looking for N here, which means that we need to take moments at A, because it's going to, if I do take moments at A, it's going to cancel out the forces R and F, which we don't know, which is great. And we can just use the moments. Okay, so the first, as we go along the rod, the first force that we hit perpendicularly is this one here, and that's W cos alpha, and we've traveled to A and we hit that perpendicular force. So we say 2A times by W cos alpha, and there's another force acting in the same direction. So let's go that one. So if we go along here, that's 4A along, and then we need to times it by the perpendicular force, which is kW cos alpha. So those are acting in the same direction, so we'll add those together. So that's 4A times by kW cos alpha, and that's going to balance with this force here, which is 3A along and N perpendicularly. So it's 3A multiplied by N to work out the moment of that force. So we do 3A times by N. Now I've not done the triangle for alpha, so let's do that now. And we're told that tan alpha was 1/3, so 1 in the opposite, 3 in the adjacent, and therefore the hypotenuse will be 9 plus 1, 10 rooted. Okay, so we could take out a cos alpha, and we know cos alpha now is 1. No, it's not. It's 3 over root 10. So we could take that out of these two terms here. So we've got 2A, and in fact we can actually cancel out all the A's as well. So let's do that, because that's times by A, that's times by A, that's times by A. So take out a cos, and then we've got 2W plus 4KW is equal to 3N. We can actually now cancel out a 3 on both sides as well. And we can also take out a factor now of 2W from inside the bracket. So we get 2W over root 10 is equal to 1 plus 2K. And that's equal to N. Okay, so then we can finish up by rationalizing this. So timesing top and bottom by root 10 is going to give us, well, exactly what we need, isn't it? It's going to give us this root 10 over 5, W1 plus 2K. Let's just double check that by doing 2 over root 10. Yeah, it gives us 10 root 10 over 5. Perfect. Okay, so that's our final answer. Okay, now it says that the coefficient of friction between the rod and the ground is 3/4. Show that for the rod to remain in equilibrium, K needs to be less than or equal to 2 over 11. Okay, so we've done moments at A, which means now the most likely thing we need to do is resolve the forces both vertically and horizontally. Okay, so let's do that. Let's start with the vertical forces. Okay, so what have we got going up? So going up, we've got R, and we've got N cos alpha, and down we've got W, and we've got KW as well. Okay, so we've got R plus N cos alpha is equal to the downs, which is W plus KW. Okay, perfect. Now, R is what we're going to need to work out. So let's just rearrange this for W plus KW minus, and we can substitute in N, which we know is this. And then that needs to be times by cos alpha. And cos alpha is 3 over root 10. Like so. Okay, great. Now, this is going to cancel with that. We can multiply out these brackets now. And the reason why I'm trying to work out R is because we're going to be looking at that friction equation. Friction is equal to mu R. Okay, so expanding out, it's going to give us minus 3/5 W, and then minus 6 KW over 5. Okay, so let's collect up the W's. We've got 1 minus 3/5, so that's 2/5 W. And the KW's, we've got 1 minus 6/5 is minus 1/5 KW. So we could write this as W over 5, 2 minus K. Okay, great. So now it's over to the horizontals. Okay, and what we'll do is we can't take that much further, but we will bag it up because we're definitely going to be using that. Okay, so now to the horizontals, and the horizontals, we have the frictional force needs to balance with n sine alpha. That's it, that's the only ones going horizontal. So friction is equal to n sine alpha. Okay, so n, as we said before, was root 10 over 5 W 1 plus 2K. And we're timesing that by sine alpha, which from our triangle is 1 over root 10. Okay, great. So we can cancel the root 10, like so. And we get that's equal to just W over 5, 1 plus 2K. Perfect. Okay, great. So we'll do exactly the same. We'll bag that up. And then we need to connect these two up. And what we know is that the frictional force will work to however much it needs to. It won't necessarily work to its max if it doesn't need to. So we can say the frictional force is always less than or equal to the mu r. So we know the frictional force is less than or equal to mu r, which means that mu is greater than or equal to, just rearranging this, the frictional force over r. And we know what mu is, don't we? Yes, mu, we're told, is 3/4. Great. So we know then that 3/4 is greater than or equal to the frictional force, which we can see there is W over 5, 1 plus 2K, over the reactional force, which we can see here is W over 5, 2 minus K. It's just out of shot on the screen, but there it is there. Okay, great. So now we can cancel and cancel. And then we can multiply, and we can cross multiply. So we get 3 lots of 2 minus K is greater than or equal to 4 lots of 1 plus 2K. We can expand out as you can see here. And what are we trying to show after all of this? That K is less than or equal to. So let's minus the 4 from both sides. Let's add the 3K to both sides. And therefore we get that K must be less than or equal to 2 over 11. Right, that was a beast paper. I really hope you enjoyed it. And what I'm going to do now is talk about my live session, because I've created and compiled 2 more predicted practice papers for this year's paper 3. And you can join me live on Sunday, the 14th of June. And I'll be going through those papers. And if you do sign up to the session, then you can vote for which questions you'd like to see me do live. It's a 3-hour session. You can ask me questions as we go along, and I make sure that every student in a session is understanding exactly what's going on, and I'm answering questions as we go. And then after the session, you get full work solutions and video solutions to any questions we didn't have time to do, and a recording of the session. I've had really good feedback over the last 2 years, and my sessions are great. 5-star reviews, really nice comments. If you are watching this post the session, then you can get all the resources and the recordings of the session just by clicking on exactly the same link. Good luck in your exams. Remember, revise as much as you possibly can, and good luck. Bye for now.